Welcome to the deep dive. Today, we're getting into something really fascinating and honestly, moving incredibly fast. It's the whole area of deep agents.
Hmm.
Now, if you're thinking about, the usual AI systems, the ones that follow rules or just give you pre-baked answers, our sources make it clear deep agents are, well, a whole different ballgame. We're talking about these pretty sophisticated digital brains. They actually combine deep learning with something called agentivity, and they use that combo to tackle really complex problems.
That's exactly right.
Yeah.
And agentivity, just to clarify, it's really about the ability to, perceive what's going on around them, process information, reason things out, make plans, and then execute tasks
Mm.
autonomously. And a key part is adapting to environments that are constantly changing. So yeah, our goal here, our mission for this deep dive is really to give you a solid, clear picture. What are deep agents? How do they actually work? What's their potential impact, which is huge? And also, what are the big challenges? Think of this as your shortcut to getting properly informed on this really cutting-edge tech.
Okay, let's unpack this then. So what are these deep agents really when we get down to it?
Right. So at its core, a deep agent is basically a software entity. Sometimes it can be hardware too, but mostly software. And it operates with a high degree of autonomy. Its intelligence, the smarts, comes mainly from deep neural networks. These networks handle the core cognitive stuff, things like perception, reasoning, planning, and then actually doing things to reach complex goals. And this is where it's fundamentally different from, say, a simple chatbot you might interact with online. A chatbot is mostly following a script, right, or pulling info that's already there. A deep agent, though, it can actually investigate, synthesize information, create new things, and act. And it does this based on understanding the context in real time. It's not just fetching data. It's figuring things out and then, making something happen based on that.
Ah, okay. So if I'm getting this right, it's not just about the agent finding an answer. It's about the agent figuring out how to find the answer and then maybe even doing something with it. That sounds like,
Yeah.
yeah, a whole other level of independent problem solving than what we're used to. Okay, so that brings us to the really interesting part. What are the key characteristics? What makes these agents deep and agentic in a way that actually matters?
Well, the deep part, that comes directly from using deep learning. That's the foundation of their intelligence. They use those powerful neural network architectures. You might have heard of CNNs, convolutional neural networks for vision, or maybe RNNs and transformers for language. And these networks power a few key things. First, perception. So their ability to analyze complex data images, audio, text, video, you name it. Then there's reasoning and decision-making. That's processing all that info, spotting patterns, figuring out relationships, making logical choices. And finally, generation. This is really powerful. They can create new stuff, text, code, designs, even complex solutions.
Okay, that covers the deep part. What about the agentic side?
Right, the agentic bit that points to their autonomy. They're designed to operate with minimal human oversight.
Hmm.
This means they could develop their own plans. They could adapt those plans on the fly if new information comes in or if the situation changes. They can even ask for more information if what they have is unclear or just not enough.
Hmm.
And what's really a game changer is their ability to handle complex, multifaceted tasks. We're not talking simple, single-step actions here. Think about problems with multiple steps, needing info from lots of different places,
Mm-hmm.
using interconnected skills, like advanced research. Not just finding papers, but maybe synthesizing findings from really different fields to suggest something totally new.
Wow.
Or think about automating workflows. They can interact with different software systems, CRMs, ERPs, Slack, whatever, connecting them, and streamlining complex business stuff. They could also generate really sophisticated content detailed reports, multimedia presentations, functional software, maybe even full business proposals. And they're good at solving open problems, dealing with ambiguity, finding root causes, proposing creative solutions. And tied into that agentic behavior are some specific capabilities, like self-correction and feedback. They watch what they're doing, see the results, spot errors, and then adjust their approach. They also have memory and continuous learning. They remember past experiences to get better next time. And, maybe one of the coolest bits, dynamic tool usage. They can figure out which external tool they need, a search engine, a code compiler, design software, and just pull it in and use it for the job.
Huh. So it really does sound less like, a fancy calculator and maybe more like a really adaptable apprentice, someone who's always learning and knows which tool to grab.
That's a pretty good analogy, actually. The apprentice idea captures the learning and adaptability.
But where does that break down? Is there a limit to that apprentice idea?
Well, the key difference is probably scale and speed. An apprentice learns from a person, from direct feedback over time. A deep agent, using deep learning, can learn from absolutely massive data sets and through incredibly fast self-correction cycles. They can sometimes spot patterns or solutions a human might miss just because of the sheer volume of data they can process, and they do it way faster than any human apprentice could.
Right, that makes sense. The scale is just different. Okay, so with all these abilities, what does it look like when they actually do something? How does a deep agent go from getting a task to finishing it?
Yeah, good question. While the exact architecture inside can vary a lot, they generally follow a kind of iterative loop. It usually starts with objective perception and understanding. Basically, it gets a request or a problem. It uses its language models to figure out the context, the requirements, and often breaks down a big goal into smaller, manageable steps. Next comes strategic planning. Based on that understanding, it formulates a plan. This means figuring out the steps, the tools needed, where to get information, and importantly, what success looks like, the criteria.
Right.
Then it moves into information gathering. This is where perception and research happen. It might search the web, query databases, read documents, analyze images, whatever the plan requires. And deep learning is vital here to sift through tons of data and pull out what's actually relevant. After gathering the info, it's time for analysis and reasoning. It processes everything it collected, synthesizes it, evaluates it, looks for connections, draws conclusions. And what's interesting is, if it hits a snag, finds inconsistencies, or realizes it needs more data, it can actually loop back. It might go back to gather more info or even rethink the plan.
So it's not strictly linear then?
Not always, no. That looping back is key. Then, assuming it has what it needs, comes execution and result generation. It carries out the plan. This could mean writing text, generating code, creating images, maybe interacting with other systems like sending an email or updating a database, or presenting the final solution.
Okay, makes sense.
And finally, there's the review and refinement stage. This is a crucial feedback loop. The agent looks at its own work. Did it meet the goal? It might self-verify, compare the output to the original request, maybe even ask for human feedback if designed to do so. If it falls short, it can adjust the plan, get more info, tweak the output, and try again. It keeps iterating until it gets it right, or as right as it can.
It really is like a perpetual motion machine for solving problems, constantly learning from what it just did. That's pretty powerful, almost like having that perfect intern who never gets tired and actually enjoys the grunt work.
Okay, so this is where it gets really practical, where the rubber meets the road, you could say.
Yeah.
Where are we actually seeing these deep agents making a difference, or where do we expect them to, really shake things up?
Oh, the potential impact is huge across loads of sectors. Take business and operations. We're looking at really intelligent automation. Think about agents automatically generating complex financial reports or marketing analyses, optimizing supply chains, managing logistics, even helping with business development, doing deep market research, analyzing competitors, figuring out market entry strategies. And customer service could be transformed. Imagine an agent diagnosing really complex technical problems, accessing all the relevant customer history, and then coordinating the solution across different departments, all automatically.
Wow, okay. What about science? R&D. Yeah, R&D is another massive area. Deep agents could dramatically speed up scientific research. They could track all the latest papers, synthesize findings across disciplines, help design experiments, even suggest new hypotheses in areas like medicine or materials science. And for big data analysis, they'll be essential for finding those hidden patterns and correlations in enormous data sets that humans just can't sift through effectively.
And I guess software development too.
Absolutely. In software development and engineering, we're heading towards what some call autonomous programming. These agents could potentially generate code, find and fix bugs, refactor existing code, maybe even deploy applications, all based on high-level descriptions of what's needed. They could also help design complex systems, planning the architecture, choosing the right technologies, mapping out the implementation.
Okay, and content, media.
Yep, content creation and media too. Prepare for much more sophisticated multimodal content generation. We're talking agents creating articles, scripts, presentations that automatically include graphics and video elements, maybe even running entire marketing campaigns. And in design, like graphic or web design, they could create functional websites or visual assets based purely on text descriptions.
So it's really shifting from just helping us with tasks to, well, taking on entire projects. From the initial idea all the way to the finished product, that's a huge leap. But with potential this big, there have to be some major hurdles, right? What are the big challenges we're facing with deep agents right now?
You're absolutely right. It's not all smooth sailing. There are significant challenges. One of the biggest is reliability and control. You might have heard about the hallucination problem with large language models. Well, deep agents can have similar issues, sometimes generating incorrect information that sounds very plausible. So ensuring they're consistently accurate and reliable, especially when the stakes are high, and making sure we can actually control their output precisely, that's a major focus.
Right, the hallucination issue. I've seen that.
Then there's transparency and explainability. This is often called the black box problem. Because deep neural networks are so complex, figuring out how an agent reached a specific conclusion can be really, really difficult. This makes it hard to trust them fully, hard to audit their decisions, and tricky to assign responsibility if something goes wrong. That's a big deal for critical applications like in finance or engineering.
Yeah, the black box thing sounds worrying.
Security is another vital area. These agents are autonomous. They might have access to external systems, sensitive data, so they need incredibly strong safeguards. We need to make sure they can't be easily manipulated or hacked, preventing them from being misused or causing unintended harm.
Okay, what else?
Well, on a practical level, there are the computational costs. Training these complex models and running them, especially if they need to interact with the real world and do a lot of reasoning, requires enormous computing power. That can be very expensive, which currently limits who can really develop and deploy them at scale. Also, error management and debugging.
Yeah.
Finding and fixing errors in these complex autonomous systems is much harder than with traditional software. It's not like finding a bug in a specific line of code.
Right, it's more systemic.
Exactly. And finally, maybe one of the most important aspects, human-agent interaction. We need to figure out the best ways for humans and these agents to work together. How do we design interfaces for effective collaboration? How much supervision is needed? When should a human step in? Finding that right balance of autonomy and oversight is crucial, and it's still an active area of research.
Yeah, these definitely aren't just technical problems, are they? They sound like much bigger societal questions we need to grapple with as this technology keeps advancing. So to wrap up, deep agents really do feel like a major leap forward. It seems we're moving beyond AI just helping us make decisions to having these autonomous systems that can actually execute tasks and learn independently. They genuinely look like catalysts for huge boosts in productivity, innovation, and efficiency across so many fields.
That sums it up well. We really are standing at the edge of a new era, I think. An era where AI isn't just processing information passively, but actively doing things, creating things in intelligent, purposeful ways. And maybe that leaves us, and you listening, with a final thought to chew on. As these powerful digital brains become more and more autonomous, what new roles, what new responsibilities do we as humans need to step into to make sure we harness this incredible power responsibly and effectively?